reaction that we are going to see, students, that is called as aldol condensation. Here, students, you have aldehyde and ketone, students. How it is reacting? If you keep aldehyde and ketone in NaOH basic, what happens, students? It will condense and it will give the compound that we are going to see here, students. So aldol condensation, aldehydes containing at least one alpha hydrogen. So which type of aldehyde is going to be condensed, students? Aldehyde, students, there's so many types of aldehyde. So we will take that aldehyde which contains one alpha hydrogen. Atom undergoes a reaction in presence of dilute alkali. So students, here the aldehyde self-condense. That is, it is also called as, if you are keeping same type of aldehyde, so that is called as self-condensation. Okay, students, aldehyde containing at least one hydrogen atom undergoes a reaction in presence of dilute alkali like NaOH, KOH or sodium carbonate as a catalyst to form beta hydroxyaldehyde. It will form beta hydroxyaldehydes. After condensation, this reaction is known as aldol reaction. This is called as what? Aldol reaction. So what is aldol reaction or aldol condensation? So aldehyde is condense itself and it will form the beta hydroxyaldehydes. It is called as aldol reaction. Example, I am taking, students, that is acetaldehyde. See here, students, two molecules. I am taking, students, aldehydes. So two molecules of aldehyde, students, they are going to be condensed in presence of, this is reversible reaction, students. So in presence of NaOH, or you can say KOH or sodium bicarbonate, students, what happens, students? They will condense. There's a condensation reaction will take place. Condensation. They will condense, students. That means these two molecules will join to each other. So what happens, students? Here this hydrogen is called alpha hydrogen. Now what happens, students? In second molecule of acetaldehyde, these both are acetaldehyde. It is also called as ethanol. Containing two carbon we call as ethanol. In common name we call as acetaldehyde. So two molecules of acetaldehyde, students, they will condense. So what happens, students? The hydrogen of this acetaldehyde now combines with hydrogen, and this double bond between carbon and oxygen will become single bond. So what happens, students? It will form CH3 and it is converting OH, and this is your hydrogen. Now it will attach to this. So there is a formation of acetaldol. There is a hydroxy group as well as what? Aldehyde group. But it is made up of acetaldehyde, so we call as acetaldol. So there is a formation of acetaldol. Okay, students. Now what happens, students, when you heat this molecule? If you heat, there is a elimination of water molecules. This will combine. These both will combine and gives water molecule. There is elimination of water molecules. Now what happens, students? This one electron of this bond will come and there is a formation of double bond. So you are getting CH3, CH will be there, and there is a double bond between here. Okay, students. So there is a formation of butanol. When you start counting, students, 1 and 2, 3, 4. There is a 4 carbon. At carbon number 2 you have double bond, so we call as butanol. En stands for double bond, and because of this aldehyde we call as Al. So butanol as a unsaturated aldehyde we are getting. So there is a formation of unsaturated aldehyde which is stable. This is a stable product, students. So this is all about the aldol condensation. Ketones containing at least 2 alpha hydrogen undergo aldol condensation. If ketone is, students, there, if it is containing 2 alpha hydrogen, then only this ketone will condense and they will form aldol condensation, and the reaction gives alpha beta unsaturated ketones. Okay, students. Say for example, students, so 2 molecules of ketone. Here I have taken acetone, students, in presence of barium hydroxide, students. So this reaction is also reversible, students. So what happens, students? They will go condensation. Now what happens, students? This will be CH3, C. Now this, there is alpha hydrogen, students. This alpha hydrogen now combines and it will gives you OH. This methyl I am writing here, students. This is methyl. Now it will condense to this CH2. Now there is a ketone group you have, students, and you have hydroxyl group. So that is why it is also called as ketone. We have prepared from ketone, that is acetone. These two molecules of acetone, when condensed, students, it will gives you ketone as well as OL, that is hydroxyl group, students. So this is also called as ketone condensation. It is also called as what? Ketone condensation, students. Now what happens, students? This is unstable product. If you heat it again, students, what happens? This OH combines with this hydrogen and there is elimination of water molecules. Because of this water molecules, students, they will form the double bond. One electron will come from this bond and they will form CH3 double bond with CH, and we are getting compound like it is. When you start the counting, students, this is 1 2 3 4, and fourth you have, students, methyl group. So it is called as 4 methyl. Total 5 carbons are there, students. So it is 4 methyl pentane. At carbon number 3 you have double bond, so we call as pent 3 enol. And carbon number 2 you have ketone group, students, so we call as 2O-one. So this is the compound, students, 4 methyl pent 3 enol and 2O-one. Sometimes it is also called as mesityle. In common name we call as mesityle oxide. It is also called as mesityle oxide. So this is alpha and beta unsaturated ketone, students. It will give alpha and beta unsaturated ketone. Why it is alpha, students? This is alpha and this is what? Beta. So you are getting 4 methyl pent 3 enol 2-1 mesityle oxide.